Hello everyone. In previous video tutorials, we already shown that the complete solution of the differential equation is y is equal to complementary function plus particular integral, where complementary function is general solution of the differential equation f dy is equal to 0. In previous tutorials, we discussed different methods of finding the complementary function. Now in this lecture we will discuss the concept of particular integral and some important points related to particular integral. So let's start with the concept of particular integral. Consider the differential equation f dy is equal to q. Now the particular integral of the differential equation 1 is expressed as 1 upon fd of q. The expression 1 upon fd of q denotes some function of x which has no arbitrary constant, and when fd operated upon 1 upon fd of q gives q, that is, in particular, consider d of 1 upon d of q is equal to q. As we know that d stands for d over dx, so we get d over dx of 1 upon d of q is equal to q. Now integrating on both sides, we get 1 upon d of q is equal to integral of q dx. So 1 upon d stands for integration, which is inverse operation of differentiation. Therefore, from equation 2, 1 upon fd can be regarded as the inverse operator of fd. So in particular, we have to remember that d stands for differentiation and 1 upon d stands for integration. The particular integral of the equation f dy is equal to q will be 1 upon fd of q because it satisfies the given differential equation. Now we will discuss some important points related to particular integral. First, particular integral never contains any arbitrary constant. Second, suppose q is equal to where u1, u2 up to un are constants or some function of x only. Then we have third, suppose c is an arbitrary constant and q is some function of x. Then we have fourth point, in 1 upon fd, fd can be resolved into linear factors. That is, fd can be written as, next point, 1 upon fd can be broken into partial fractions. For example, 1 upon d square minus 1 of q can be written as, next point, suppose c is any constant and fd is d, then we have. So in this lecture we discuss the basic concept of particular integral with some important points. In coming video tutorials we will learn how to find particular integral. First, when q is equal to e power ax. Second, when q is equal to sin ax or cos ax. Third, when q is a polynomial of x. Fourth, when q is equal to e power ax into v, where v is any function of x. Fifth, when q is equal to x into v, where v is any function of x. And sixth, we will discuss general form, that is, when 1 upon fd of q is in the form of 1 upon d minus alpha of q. I hope this lecture was helpful to you. If you have any query or any suggestion, please write in comment box.